3 is, so welcome to GIS Day at Tennessee State University. This is the 4th and last edition. And so the students are approaching. And so this is group 3. Again, this is Dr. David A. Padgett. I'm going to sit out here, and the students are going to walk up to there. Whoever is in Brandon Allen's group, or group 3. So just please pull up your map. And please pull up your map. Let's see, and then we'll go through the process of the map demonstration. We have 3 groups, so we don't have time for goofballing around today. Not that we ever goofball around in here. Let's see, let me write this down. What the hell? Oops. Any damage there, did I? Hopefully not. Okay, so we are about to get started here with group 3. Just log into ArcGIS Online.
I got it. It's just the link was on the power.
Oh no, you can just log into your account on ArcGIS Online. You don't remember? Okay, so for those of you who are joining us today, we have our World Regional Geography class at Tennessee State University. Again, I'm Dr. David A. Padgett, and this is our 4th and last group, well, 4th and last class section of World Regional Geography. Okay, so first, the students will speak into the internal camera there, your name, your major, where you're from, one at a time, and then we'll get started.
Okay, I was going to say it's kind of funny because I look short in this camera. But my name is Sydney McGee. I'm an architectural engineering major from Knoxville.
Okay, thank you very much.
My name is Demonte Timberlake, and I'm a political science major.
Thank you very much.
My name is Christian White. I'm a therapeutic studies major from Orlando, Florida.
Thank you very much.
My name is Brandon Allen. I'm a commercial music major from Nashville, Tennessee.
Thank you very much. Thank you very much. Okay, so you have your map pulled up. We have, let's see, I don't have my glasses on, but it looks good so far. So let's look at our data here. So we have, okay, zoom out a little bit, please. Man, this screen. Zoom out a little bit more. Okay, that's interesting.
Our points, for some reason, were the same location, so they overlapped over top of each other.
Yeah. Okay. Well. I mean, we can't fix that, but we can work around it. So just zoom in on the courtyard northwest point. Okay. So let's see. Click right on that symbol. Okay. So let's see. So we have. Okay, that's interesting. So we have the old courtyard northwest sample site. So what the students did, for those of you who are listening in, is they participated in the GLOBE program atmosphere protocol, which involves hands-on scientific inquiry And so the students earlier this semester collected some atmospheric data. And so the data included the ambient temperature and the surface temperature. And it looks like for this site, what's your average surface temperature for this particular site?
39 degrees Celsius.
So it's 39 degrees Celsius, and the current temperature was 27 degrees Celsius. Can you see that little arrow that's at the top of the dialog box? Yeah, that one. Click that one again. So let's see. So this is old. So notice that your data, you do have your data in the database, and just something happened with the symbology. That's all. So we're going to try to figure out what happened. And we're all learning here. These are all, well, not all freshmen, but these are all first-time GIS users, and we're going to make mistakes, but as long as we learn from our mistakes, that's fine. Miss McGee, could you scroll up the legend a little bit? The legend over on the right, left. Yeah, just bring that up. Let me just see. Okay. Let's see if we can work around this somehow. So we do have two data layers. Okay, so go to, okay. Hydrating. So go to content. I don't know. Go to content and click on the first layer, the globe data collection sheet. Let's see. Click on that, the change style. Yeah, let's see. Change style. And let's see. So change that to surface temperature, average surface temperature. Okay, then hit done. Okay, well, we're getting somewhere. Okay, go back to that again, do that same thing. Yeah, and then go back to change style. Go to options, symbols. All right, change that fill, go to fill, and then change your fill to like a red, a nice red. Yeah, solid red, and hit OK. All right, hit OK at the bottom. Let's see, OK. Hit done. Let's see. Go to go back to that same layer again. Go to those three little dots. Go to what? Oh, this is okay. Go back to legend. All right, this is. Wait a minute. Okay, go back to content again. That's strange. Okay, go to the second layer again. Click on change style. Options. This is strange. Symbols. Okay, fill. Change that to like yellow. Yeah, yellow. That should have a real. Whoa. Okay, that's kind of yellow. Okay, hit done. It's close enough. Okay, hit legend. Go to legend. This is kind of. The problem is this screen. That's the real problem. This is horrible. Well, I guess I shouldn't be saying that on a recorded, but anyway. But it is what it is. So if you can barely see that. I don't know. Zoom out a little bit. Maybe no, it's just not going to come into focus. Yeah, turn this other light off. I mean, it's going to help it a little bit, please. Yeah, that'll help a little bit. Thank you. That'll help a little bit. All right, so let's see. So your current temperature is, let me see. Well, just click on the point symbol. The image is so corrupted that I can't. Just click right on the point symbol on the map. All right. Oh, yeah. So your current temperature, so the old courtyard lawn, yeah, all 4 of your data sets are at one point. It happened, but it is what it is. So for the old courtyard lawn, you have a 5 degrees Celsius difference in temperature. So go to hit that little arrow again. Site 1. So the old courtyard northwest site has an 11 degree, difference in temperature. So now the land surface is not correct, but it's supposed to be concrete. So let's say the land surface was done correctly. Anybody, is this what you would expect? Would you expect for there to be a greater difference in temperature between your surface temperature and the ambient temperature at the old courtyard northwest site, which was on concrete? Yes? Everybody agree? Yes. But so that's fine. I was a little confused at first because I forgot this is my latest class. So by the time you all went outside, you were getting close to the warmest part of the day. So the warmest part of any normal day is not noon. Noon is when you have the most intense sunlight. But remember, what instrument did you use to collect the surface temperature data? What was that called? Okay, it was an IRT. What did that I stand for? What did the IR stand for? Well, it stood for infrared, right? So infrared radiation is long wave radiation. So what happens is short wave radiation comes in from the sun, is absorbed by the earth, then is released from the earth as long wave radiation. That long wave radiation is absorbed by greenhouse gases such as carbon dioxide. There's a lag time between the time the earth absorbs the short wave radiation and releases the long wave radiation. So therefore, the hottest time of day does not occur simultaneously with the most intense incoming shortwave radiation. It happens a little later, usually between 2 o'clock and 4 o'clock p.m. in the afternoon, which is about when we were outside. So your class got a lot more, I don't want to say accurate, a lot more of what we would expect to see. The other classes that went out early in the morning didn't get this result. Okay, so click the arrow one more time. Let's see what else we have here. Okay, old core. Okay, one more time. So basically we have duplicates. Let's see what happened. Let's see exactly what happened. Go to content again, please. Doing some forensics here. Click on that. Yeah, click there. And then this time open up your attribute data table. Yeah, the table. Yeah, that right there. Okay, now there's your table. Okay, let's scroll through your data. Now, the one good thing that you did was that you all of your data set's clean. Everything, there's no characters in with your number data. Keep scrolling. Oh, wait a minute. There's some. Yeah, keep scrolling the other way. No, the other way. Back where you were. So now one thing that we did have was a decent cloud cover, right? Which is interesting. Let's see, what your percent cloud cover was what? Go scroll back across.
10.
Yeah, only 10%. So you had pretty intense sunlight that day. And so we got the results we would expect with the concrete giving off a higher temperature than the grass. Let's scroll across to the land cover. It's the other way. Let's see what happened there. Let's see. Keep going. Old courtyard. Yeah, we kind of got those reversed, but that's okay. It should be concrete, period, at the old courtyard northwest. There's, we can't really see it from this image because the trees are in the way. And then the old courtyard lawn site, of course, would be grass. You can clearly see the error there in the database. But that's not a problem. We all make mistakes. You're learning. So one last question. I'll ask this to Alan. So you're familiar with the urban heat island effect?
The what?
Urban heat island effect?
Urban heat, what effect?
Urban heat island effect? Okay. Well, phone a friend. Somebody in your group wrote a really good essay about the urban heat island effect. Was that McGee? So what's the urban heat island effect?
To the best of my knowledge, the urban heat island effect, it was about cutting down vegetation and replacing it with concrete, and that causes a rise in heat temperature, and that causes like health problems and pollution.
Yes, so you all can, I guess, easily see how this kind of, bring your legend back up, please. Your legend, yeah. How this kind of analysis can assist in the examination of, well, you can get a quantitative depiction and a visualization of the urban heat island effect in showing that clearly, well, maybe perhaps not on this map, but had you had the correct who knows how that happened, but had you had the correct latitude and longitude, you would have seen visually the difference between the data that you collect on the grass surface versus the data that you collected on the concrete surface. So would the radius of the symbols at the grass surface, if they were there, would they be, let's try something. Go back to content. Go back to content just for a second. Okay, take the check mark off of the second layer. Okay, so now let's see. Now click on the symbol. Let's see which one that is. Okay, that would be, zoom out a little bit. Zoom out. So that's your old courtyard lawn. Whoa. Yeah. Well, you were fine. You were fine at first. Yeah, just out. Zoom back out. Yeah. So that's the old courtyard. Oh no. Just take that away. Just take that. So that's the old courtyard lawn. Go back to your legend. So that's your old courtyard lawn result. And now if you go back to content, replace the check there, remove the check on this first layer, and then there is your courtyard northwest. Click on it. I guarantee you that's what that is. Yeah, a few mistakes in the database, but other than that, decent job. Little lat long error, but that happens to people. It's your first time using this software. So overall, good job. You can close that out. Have a seat. Group 3. Thank you very much. And yes, give them a hand. That was a good job. All right. So yes, we're going to continue here at Tennessee State University's, and part of the reason that I wanted you to log in was you could have maybe fixed those errors if you had been logged in. So we're going to have group 2 come up here, and group 2 is comprised of, let's see, group 2 is Jaden Johnson, Dildy, D, Brantley, Common, and Jakai Jackson. Not Common, the R&B artist, but Common, the student. Okay, so same thing as before, just speaking to the embedded camera there. Introduce yourself, name, major, where you're from, and then we'll get started.
Hi, my name is Gabby D. My name is Sierra Common. I'm a nursing major and I'm from Chattanooga, Tennessee.
My name is Jakai Jackson. I'm from Atlanta, and I'm an architect at the university.
My name is Cody Brantley. I'm an architectural engineering major and I'm from Akron, Ohio.
Okay, so whoever is going to be our pilot can, whoever has the account can sign in, and then we'll get rolling here. So, excuse me, what? Oh, yeah. So the students are now getting ready to present their map, we hope.
Yeah, I can't remember my
I can't.
You want me
Yeah, yeah.
login. Yeah.
Whose account? Whose
It was
account?
my account, but
Oh,
I can't remember.
okay. So we're just focus. So we're just getting logged in here. So this is the first step. Is every student, well, not every student, most of the students have their own ArcGIS Online account, which is a free account. It's a fully functional geographic information systems program. And okay. Well, wait. See where it says forgot password? Try that. Okay.
Which email do you use?
Oh, that's a great question.
There was a thing where we saved our password and
So, now you need your. So while we're waiting, just a few technical difficulties, but that goes along with using any technology. You're gonna have difficulties with technology all the time, but just have to be patient and work through it. Working with technology is, it is what it is. I mean, I've owned a GIS consulting firm for 30 years, and patience is definitely a virtue. All right. So we're waiting now for, we might have to go to Plan B.
Yeah, I think I just have
So,
it's the last tab.
the last time.
Yeah, all the way down.
yeah, what's going on here? Okay. Yeah, it's not the sheet. All right. So hopefully we'll be getting started here again. So if you're watching from wherever you are, welcome to GIS Day at Tennessee State University. Okay, now we're gonna get rolling here, hopefully. Okay. Wow, this is interesting. Okay, so first of all, well, do you notice something that's a little interesting about your data, about your map?
Is it different?
What's that?
Okay, so the longitude and latitude that was written out on sheet paper, but I had put it in the base map, it went to like two different parts of like Nashville. It was anywhere like near campus.
Okay.
So, I went to Google Maps and I had to like.
So you approximated the lat long
Yes.
through damage control, but you didn't really remember where we were when we were outside. Is that what happened?
Well, I had right clicked on that area where the.
Okay. Yeah, that's
That's
close. But the second point, I guess you didn't really remember where we were exactly,
I did.
because we weren't there. We
Like the other side.
we weren't quite there.
Right here.
Yeah,
I
yeah,
right clicked right here, and then when I put in, I don't know, I probably messed up on my part.
yeah. So there's obviously is the latitude or longitude the error here?
The longitude.
Yes, the longitude, a little bit too far to the east. Okay, so Let's see. So you did a good job, reasonably good job. Let's try something. It looks like your average surface temperature data is, you did a good job with your legend. You're able to change the name of your layers. So let's click on average surface temperature, IRT. Oh no, go to content first, I'm sorry. Now click on average surface. Go to, there. Go to options. No. Yeah, options right there. Go to symbols and go to fill. Change that transparency to maybe 50%. Let's see what 50% transparency looks like. Okay, hit OK. Then hit OK again. Okay, that's a little better. Hit done. And then pull both sample points into the view. You're on the map. Your second, okay. Okay, zoom in just a little tight. Just right there. Okay, now bring your legend back up. Now, I'm not going to give you a hard time, but remember you were supposed to convert these numbers into Celsius degrees, but I'm not going to give you a hard time. Okay, so what do you notice about the difference between your grass surface data and the other data? Are they the same? Are they different? If you look at the symbols, what do you see that's different about those two values?
The average surface temperature is higher
Where?
in the grass than the shaded area.
Well, that's interesting. So that's really almost the exact opposite of what we had with the first group, right? The first group had totally different. The first group had what we would expect. Now this is interesting. This makes us start to say, right? Start to think maybe there's a mistake, but we're not going to worry about mistakes in the data right now. So notice that both values for your Old Courtyard Northwest site are, let me ask you, are both values, or both results for your Old Courtyard Northwest corner site, are they lower or higher in temperature than the lawn results? They're lower, but wait, the surface, click on the Old Courtyard Northwest, but the surface, should have been concrete, but it's okay. But let's say it's concrete and the other surface was grass. Which surface would you assume would produce higher temperatures, the concrete or the grass? But that isn't what happened, is it? So what happened? What made the difference, perhaps? Why do we see a difference in terms of those temperatures that was not what we would expect?
Maybe because it's covered by trees.
Yes, the shade. Let's look at something else. Let's see. The temperature differential at the Old Courtyard Northwest corner site is, what is that? 30, is that a 6 or an 8? 76.5 or 78.5?
76.
Is it 8 or, and that screen is just, okay, so we have about a, 36.5 degree Fahrenheit difference. Let's go over to the Old Courtyard lawn point. Let's see what the difference is there between the surface temperature. So we have a much greater difference. Wait a minute. Hold it. What? Okay. So apparently something has happened here. But we can fix it. We can fix it. Which one of these temperatures is Okay, let's just speed it up. So is that LFT in degrees Celsius or Fahrenheit, you think? 42 degrees Fahrenheit? Yeah, Celsius. So somebody quickly convert, what's 42 degrees? What's the equivalent to 42 degrees Celsius in Fahrenheit degrees? So it looks like D's on it, or Gabby D. Yes. Yeah, converting Celsius to Fahrenheit.
107 degrees Celsius.
Now that's what?
107.6.
Okay, apparently that's just not possible, right? Because we were all out there, right?
Yeah.
And I'm sure we would have definitely remembered if it was 107 degrees Fahrenheit.
I think it's wrong.
So, sometimes we have to go back and look at our data and say, maybe that isn't right, just based upon logic. Okay, but one thing, well, let's see. Let me see. I guess, who's in this group? We've got engineer, I don't know. Oh, Common, you're nursing, right? So any of you, well, what do we notice? We notice that the trees, we have two engineers here. The trees definitely have an effect upon the temperature, right? In engineering design, what do we call engineering design when we incorporate natural materials into building design? What do we call that? You're freshman. It's called, what's that?
Wait, I mean, I feel like you could just, what were you gonna say?
No. What were you going to say?
I mean, you're talking about like environmental sustainability engineering, I guess.
Yeah, close. Yeah, that's good. Yeah. But the technical term is green infrastructure design. That's when you keep the trees around, and it cools things off. Now, from a health standpoint, Miss Common, right? Now, we are looking at data related to the urban heat island effect. Did you all discuss any of the health issues that could be exacerbated by urban heat? What is one? Well, let me just make it a little easier. What's a respiratory problem that could be very much exacerbated by the urban heat island effect?
That's a good question. I would say like oxygen.
A respiratory problem. Nurse, Common. What's a respiratory problem?
Asthma?
Yes, asthma. Phone a friend, good assist. Teamwork makes the dream work. Yes, asthma. So you might ask, well, you knew probably that, that heat. Well, let me give you a multiple choice question. This is for anybody. What weather-related hazard kills the most people every year? Is it, you got heat. Well, somebody did the reading. Yes, heat kills more people than hurricanes, tornadoes, flooding, all of those. Heat is the deadliest weather hazard. And so when cities get hot, people die. Usually from heat stroke. That's usually elderly people, but children, Nurse Common, it's what we call pediatric asthma. African American children are twice as likely to suffer from pediatric asthma and 10 times more likely to die from asthma attacks than other kids. So you can see how, with most African Americans living in urban areas, how we really need to get this issue under control, or at least engineers some form of urban infrastructure design that will bring cities' temperatures down and will eventually result in less emergency room visits for children and really less deaths for African American children. So We study these types of things using this technology, not just to make pretty maps, but to perhaps save lives. But let's look at one more thing. Zoom out, and keep zooming. Zoom, zoom, zoom. Keep zooming. Move to the west a little bit. Yeah, toward the west. See now you know the difference between east and west. Keep going a little bit. Now zoom in. Keep zooming. Now move to the west a little bit. Keep going. Move to the south. A little bit to the west. Keep going west. Keep going. Where is it? Oh, right there. Keep going a little bit to the west. A little bit. Keep going a little bit more. Okay. So my two engineers here, we're talking about sustainable design. So we see a new home construction. See that swimming pool? What do you not see? What's not there in that apartment or townhome development? What's glaringly not there? No trees. There's not a tree in sight. And so this is that. I don't know how that happened, but that's the old way that we would do urban design. It's called what we call leveling. And so the construction site would literally be leveled off. Every tree cut down, all the grass removed. Then you'd come in and put in the parking lot and the homes and blah, blah, blah. But look at how unhealthy that is. And that shouldn't be true. I mean, that's a newer neighborhood. If you go a little bit to the east, notice that the older neighborhoods have trees, much healthier. So I don't know what happened there. I mean, so one way that cities can sometimes require developers to leave a certain amount of the green infrastructure intact. And green infrastructure increases the value of residential and commercial property. It does not take away from it. Anyway, so that's just an example of what we do not want in our cities. I don't know how that happened, but it is what it is. Okay, so thank you very much, Group 2. Yes, you can give them a hand. They did a good job. A few little boo-boos there, but hey, nobody's perfect, right? So now we have Group 3. Let's see who's in Group 3. Maybe this group. Group 1. Sorry, we're not going to do a repeat of. So this is Pena, Langford, Bryson, Leondis, Morrison, and Branch. Come on down. So do you remember your login?
No, I'm by myself.
Oh, you do have a group member with you. All right, so Branch, so did you upload the data to your Dropbox?
Yeah.
Oh, thank you. Let's see. All right, so we're just extracting the students' data at this time, and then we'll get to our teachers. Don't worry. Maybe it'll take so long he won't get to the teachers. Oh no. We're gonna get everybody up here. Let's see. So your link to your map is in here somewhere? All right, let's see. Let me close this one out. Okay, let's see what we have here. All right, I'm going to sit down and same deal as before. Just, your map's already up. So we're going to introduce ourselves, just speak into the embedded camera, and then name, major, where you're from, and then we'll get going.
My name is Mariah Branch. I'm from Memphis, and my major is psychology.
Hello, my name is Roy Payne. I'm from Memphis, Tennessee, and my major is music education.
All right. Well, let's see. So, wow. Okay. This is interesting. So we have your map. Okay, it's not as bad as I thought it was. We can work on this. So go to content. It's like somebody was playing around. I hope we can fix this. Okay, let's see. This is wow. Okay. Let's see. Go back to the legend. Okay. Click on the old courtyard northwest corner site. No, that's the lawn. What? Okay. Well, at least we have degrees Celsius. Okay. North of this corner. All right. So we have that. All right. Close that out. Okay, so click on that again one more time. All right, well, let's see. All right, go back to content. And wow, okay, go to the change style, which is the triangle, circle, and square. Now I see what's going on. Okay, see that X that's next to number of contrails? Yeah, the X that's next to number of contrails. Okay, good. Get that out of there. Okay, now hit done. Okay, now go back to the legend. Let's see if hopefully that fixed it. That didn't fix it. What in the world is going on? Okay, go back to content again. And go back to, that. Let me see. Got that there. Temperature, location. Go to options. I think I see what's going on here. Go to options. Oh, man. Oh, my goodness. Take the check mark off of that other. Wait, go to symbols. Click on that circle and hit OK. Hit OK. Still something going on here. Yes, scroll down to, see that little scroll on the side, lower right hand side. Scroll down. Let me see what we have here. Visible range. Okay, hit OK. I gotta figure this out. Scroll all the way down. Hit options again. See the three dots next to, that's not it. Okay, scroll down, scroll up, go to symbols again. Cancel. All right. Just hit OK. Let me think about this for just one more minute. Okay, under location, hit select. Yeah, hit options. Click symbols. Cancel out of that too. Trying to think. Oh, I know what the problem is. You're not logged in, so you can't. There's not a whole lot you can do just like this. Hit cancel. Let's see what we can do. Hit done. Yeah, you can't change the symbols. Go back to go back to change style. Oh, click on the three little dots. Let me see something on it. Nah, it is not a whole lot you can do. Okay, so we're just gonna have to go back to the legend. Oh shoot. Go back to content. Hit change style. Oh Jesus. Okay, go under, see where it says choose attribute to show. Change that to average surface temperature, IRT. Okay, now hit done. Go to legend. Okay, go back to content. Go to change style again. Go to options. Click on those 3 dots beside where it says, yeah, no, that's just gonna move it. Okay, go to symbols. No, just cancel out of that. Click on where it says ungroup. All right, now go to OK. Yeah, just hit done. Go to legend. Yeah, there's just too much going on here. You just can't do a whole lot when you're not logged in. So this is what we're gonna do. Go to content and go down to where the data table is. All right, so scroll, bring your data up. All right, so let's see. Well, at least the data's clean. I mean, you didn't make the mistake. Cloud cover, got all that. Go back to where you have your keep going. The other way. Keep going. Okay, right there. So we've got, just scroll left a little bit more. Just get the site names in there. All right. So let's see. Old Courtyard, Lawn, Northwest. So, well, before I keep going, so this is your data table. So, of course, your data table is the most important part of your map. The mistakes were not made with your data. So that's the good thing. That's the good news. You did not make mistakes with your data. The mistakes were made with your symbology. And I don't know what happened there, but I mean, it's okay. It's okay. It is what it is. The first time you're using the software, it doesn't make, it's just is what it is. So let's see. So for our Old Courtyard, Lawn, Northwest, north-south, we have what? 15 degrees Celsius difference in temperature. And for our Old Courtyard, northwest corner, we only have a 2.5 degrees Celsius difference in temperature. So you can see perhaps how much of an effect green infrastructure design can have by just leaving those trees there. Look at how much cooler that surface is, and it's concrete. So nature has on some of the things that cause us harm. So Branch, what's your major again? Psychology. Opinions, music. Well, anybody in the class might, volunteer to answer this question. So when we were speaking on the topic of air quality as it relates to the urban heat island effect, what we are really talking about in terms of potential harm to individuals' respiratory health is associated with a specific gas. So anyone in the audience or at the front of the room, what gas is the existence or the concentration of what specific gas what specific gases increased with the urban heat island effect that is especially dangerous to people with respiratory problems? What gas? No. There's another gas. What's that? It's not nitrogen. All the gases you're mentioning are associated with this gas that is formed secondary to those others that are released during human pollution-producing activities. What's another gas that's in the atmosphere that you've heard of? Okay, I'll give you a hint. It starts with the letter O. Okay, it's not oxygen. I'll give you another hint. Where did Dorothy go to meet the wizard? So what gas am I talking about here? Ozone. Miss Butler. Thank you, Miss Butler. Ozone. Ozone is, now, there's two types of ozone. There's two places that ozone gas is in the atmosphere. It's 6 miles above the Earth in the stratosphere. That's the ozone layer that protects us from ultraviolet radiation, right? That's good ozone, naturally occurring ozone. The ozone that's down here with us is produced via a photochemical reaction that happens more when cities are hot. That photochemical reaction produces ozone as a secondary air pollutant. And so I'm sure you've heard or seen during the summer where there's a bad ozone day. Heard about that? There's a bad ozone day. Well, that's where that ozone comes from. It comes from a photochemical reaction that, again, is increased when it's hot. So this is one of the reasons why we do this kind of research, so that we can mitigate the effects of the urban greenhouse effect. Because as we just mentioned, we know that heat is the deadliest weather hazard. So the most important thing in here is that your data is clean. You got your lat long correct. Notice that with the latitude and longitude, the data are truncated, so it's or otherwise rounded off, because we were so close together in terms of the distance between the Old Courtyard lawn location and the Old Courtyard northwest corner, that when we get down to 2 digits behind the decimal, they're essentially the same value. But we know that in our database, the value went far beyond just 2 digits. But that's just a function of the software. So obviously you did have an almost accurate Old Courtyard lawn northwest point. Did you do the same thing? Did you have to make an adjustment?
Well, I did, because where we was on the line, it was kind of like in front of the Boswell building. So I guess maybe, because when we walked straight across, like we didn't go like another direction. So.
Yeah, and another thing, remember I told you about the fact that there's an error sometimes that the GPS receivers might be off by 100 feet or so. So that's what you're seeing. Sometimes it's very accurate, but depending upon the time of day and when you go outside, sometimes you don't get as good as accuracy as other times. So group 1, good job. You know, just a couple of errors, but hey, we all make mistakes first time out. Nobody in here got on a bicycle and rode without training wheels, right? Yeah, right. You know what happened when you tried. All right, thank you very much. So we're going to move on to our, yes, give them a hand. So we do have people, we have guests listening in, at least on Facebook live feed. So now, last but certainly not least, we have our last group, our pre-service teachers, who are going to come up here and show us their data in the Globe Data Visualization System. So we have Kelly and who else? So here are teachers. Yes, same thing. Go up, introduce yourselves, and then what's your name?
Butler, a child development major from Memphis, Tennessee.
I'm Leah Perry. I'm an early childhood education major from Gary.
I'm on Kelly, I'm an elementary education major.
Okay, so you kind of slide that inset screen out of the way because you're gonna have to. One of you has to sign in. Whoever posted the data. All right. So I guess that was Butler. She's gonna sign it. So this is the Globe website again for those of you joining us. Globe stands for Global Learning and Observations to Benefit the Environment. It is a NASA-sponsored program that has its primary objective improving science education at the K through 12 level. These students are future teachers, and so they have become Globe certified, which allows them entry into the Globe system. So, well, looks like Butler knows what she's doing. So just, go to Globe Data, visualize data. Okay, so go down, go into the Globe data visualization system. And now we're going, okay, now of course you have to go and, okay, well, see, they don't need any help from me. That's what we, oh, wait. Go back to air temperature. Oh, just leave it open. Just didn't want sure that you had, okay, well, okay, good. One more. Now she's going to go down to surface temperature and submit. Oh, whoa, you have to hit submit first. You might, whoa. Yeah, there you go. Now, measurements. Okay. Well, she's just flying, man. It's just going on. Zoom in, keep zooming, and keep zooming. And eventually you'll get zooming, and it'll separate the two. Oh, okay. So here we have two observations that were made by the class. And so let's look at the Old Courtyard Northwest site first. And so notice it's the same data, but the data is visualized inside of the Globe visualization system. And so so you have this is the surface temperature data. Let's look at the, it's 29.3 degrees Celsius average surface temperature. And now let's go back and look at the current temperature or ambient temperature. Yeah, just click there again. No, yeah. See the little drop-down menu? Yeah, right, boom, yeah. Then air temperature, it's up, yep, okay, here we go. So your air temperature was what, 26 degrees Celsius there versus, what was the other one? It was 29. Yeah, go back to surface temperature again. Yeah, it's 29.3. So we have a 3.3 degrees Celsius difference there. Notice you have the chart also, the graph, excuse me. Okay, so let's go to the old court, the lawn site. All right, click there. And let's see, let's go to, let's do surface temperature. And we got 31.6 degrees Celsius there. So a little bit warmer, right? Data looks good. Now let's go to the current temperature. So the other one was what, 26? Let's see what was that. They both were 26. Well, that's interesting. But okay, so you can close that box just for now. Well, no, leave it open. Let's look at something. Let's go to photos. Let's see if we got any photos. I don't know. Did we get any photos? No, change it from land cover to sky conditions. Nope, didn't get any photos. Close that out.
So we can take pictures of that one.
Yeah, is that? Yeah, probably no. Any photos here? Probably not. Yeah, change it to sky conditions. No. Oh, we do have photos. Yeah, so we got a couple photos there. Okay, close that out. Okay, so I want you to put your teacher thinking caps on. So we were outside and we were with these responsible adults here, right? Responsible sometimes, sometimes not. But what if you had some third graders out there? How might you modify the lesson for third grade students? It was different than what we did.
Talk about when we went out, like how we assign roles to students.
Yeah, how would you remember these were adults. Not grown, but adults. Not grown yet, but adults. But so how would you change that pedagogy for a third grade class?
We had a few expensive instruments that we used. I wouldn't pass all of those out.
Really? Okay. I wouldn't pass. So what would you do? I mean, well, wait. I mean, you'd assign a few students. But I mean, I'm going to challenge you on that, Miss Butler. I mean, isn't this supposed to be hands-on scientific inquiry? Keywords, hands-on, and you're going to take the equipment out of the hands of the students? I mean, maybe, you know, I don't know.
Some students are not, like, you can let them pick which one they want to use, but everyone doesn't need to use the exact same thing.
Okay, so maybe if you have little Johnny, I was gonna say another name, but I might get in trouble because it's being recorded. Let's say little Johnny is a little rambunctious. Maybe he might not get the liquid filled thermometer, right? Maybe you give little Johnny the cloud chart. Can't break a cloud. Well, maybe. I don't think you can break a cloud chart. But 8-year-old, you never know. So you assign. So that's good. So you know your kids. You know the students. You know, like, hey Johnny, let's get this cloud chart, and maybe Jane can get the liquid filled thermometer because she's a little bit more calm and responsible. Okay, so I'm going to ask you another question. Was there a potentially really good opportunity for embedding a math exercise inside of this lesson?
You talk about changing the temperature from Fahrenheit to Celsius.
Okay, there's one. There's another one, though. There's another opportunity for you to incorporate a math lesson. Yeah, that's good. The converting from Fahrenheit to Celsius. But there's another opportunity for a math lesson. Okay, I'll make it easier on you for some reason. I don't know. I'm in a good mood today. Go click on the northwest corner site, not the lawn site, the other side. So let's see. So notice what kind of surface temperature value is that?
It's in Celsius.
No. What is it? Just read it. It's blank surface temperature. Yes, right.
Average.
Yes, average. Oh, so how many samples were taken?
We took 9 samples.
Oh, really? 9 samples, but you only entered only one. Now, when you entered the data into the desktop data entry portal, you entered the 9 values, right? So you didn't actually do the calculation, did you? The computer, the Globe program did the calculation. So how could you make this a little bit more hands-on for the poquitos?
Showing them how
Exactly. So, and then see if it matches the one that you get here. You know, so you, and it will be interesting. Break the students up into groups. Also, now, even with the liquid filled thermometer, you can get an average value, right? And it really teaches the kids, the students about data, because let's say you pass that liquid filled thermometer around and don't help them, and they read the liquid filled thermometer, write it down. Some children are going to say they're going to get, 30 degrees Celsius, 30.5 degrees Celsius. Then little David, who's might not be paying attention, might get 50 degrees Celsius, right? David doesn't pay attention, right? So now you get all your data laid out, and 10 of the children get around 30 degrees Celsius. Then you have this David kid gets 50 degrees Celsius, and that teaches students how to look for errors and mistakes, right? Because if you know that, wait a minute, this should be a value of 30, we might throw that value out and use the others to take our average. Any globe data that you collect with children, you always take the average. That way, each child has a chance to get engaged with hands-on. Each child looks at the thermometer, passes to the next child, looks at the thermometer, passes it to the next child. Then you average the data. And it's, you know, I've done this with some 9 and 10-year-olds. Is it easy? Oh, no. But you have to do it so that they can actually learn how to take and calculate an average. Okay, so go back to the lawn site. Let's see, what time is it? That can't be the right time. I guess it is the right time. How did you collect so you enter the data with this, for this site using the desktop. What did you use to enter? So you use the app for the lawn data, but you use desktop for the other data. Which one was easier to use?
I think it was easier to use the desktop, but like, it was more convenient to use the phone.
So wait, so the desktop was easier, but the phone was more convenient? Explain that.
Like while we were still there taking the data, it was more convenient to take it on the phone and having to open up a laptop and type it in like whatever.
Okay, so the real-time data entry. So which of those would you think would be more interesting to the third graders?
They probably use like a tablet with an app on it.
So would that be more conducive for learning, you think, or would the other way where you write everything down, then enter it, which one of those would be more conducive to learning, you think?
Write it down first would be.
Yeah. So but sometimes we can do things both ways. What I usually do is do things what we did the written part first, then we did the app second, so that the children will know that this app, this isn't magic, right? I mean, because if you don't demonstrate in writing or hands-on how technology works, a lot of times people won't understand it at all, and they will completely trust the technology. And sometimes if you have an instrument that spits out a bad value, usually you know that value is bad because you've done it by hand first. You sat down and you know, wait a minute, something's wrong here. This instrument kicked out a 50 degrees Celsius temperature, and we know that if it was 50 degrees Celsius outside, we would all remember it and be cursing each other out, but cursing the teacher out. No, we would never curse out a teacher openly. Okay, thank you very much. So these are our pre-service teachers, Globe certified teachers. No, you can just, what's down there? Oh, no, just keep it. Yeah, it's fine. We're fine. We're good. I'll take care of that. Thank you very much, ladies. So now, Thank you all for joining us live stream on Facebook. It's been great. Happy National Geography Awareness Week and GIS Day. You can see at TSU, our students' excellences are having at TSU where we think, work, serve. All right.